Welcome to Community Science Institute's Water Quality Database. This tutorial covers how to navigate the harmful algal bloom, or HAB, monitoring portion of our database. Right now, we're on the database's landing page, database.communityscience.org. Note that Community Science Institute is continually working to add to and improve our database. Because that's an ongoing process, what you see in this tutorial may differ slightly from what you see on your own computer screen. We're doing our best to keep these tutorials up to date as we make improvements to our database. If you look to the top left corner of your screen, you'll see the database menu. To get to the harmful algal bloom page, click here or here. Clicking that button will bring you to this page, the landing page for the HAB data. And sometimes that can take a second to load. If you're familiar with Community Science Institute's HABs reporting page from previous years, this page may look familiar. This is where you can come to see a summary of blooms on the lake. So here on the right side, you'll see this map with different colored pins. Just like they were on our HABs reporting page, the blooms are color-coded to represent the level of microcystin toxin present in each bloom after it's been analyzed in our laboratory. The blue pins represent what we call suspicious blooms. These are blooms that our volunteers have identified as potentially harmful and that we've seen photos of that look like blooms. However, they have not been observed under a microscope, so we cannot confirm 100% that they contain cyanobacteria, but these blooms should still be avoided. Black pins represent confirmed blooms. That means that we've identified cyanobacteria present in them under the microscope, confirming that they have the potential to be harmful. Results from laboratory analyses on these blooms are not yet available. Green, yellow, and purple pins are blooms for which laboratory results are available. Green pins are blooms in which the microcystin toxin concentration is below the drinking water limit of 0.3 micrograms per liter. Purple pins are blooms in which the microcystin toxin concentration is above the contact recreation limit of 4 micrograms per liter. Yellow pins are blooms in which the microcystin toxin concentration is between the drinking water limit and the contact recreation limit. And these are limits that have been set by the EPA and adopted by the New York State Department of Health. You can zoom into this map by holding the Control or Command button and scrolling with your mouse. And you can navigate within it by clicking on the map and dragging it in the direction that you'd like it to go. If you click on a bloom pin, it will take you to a page focused exclusively on that bloom, which we will do eventually in this video. You can click this button to make the map full screen, and click it again to exit full screen. Now, it's important to note that this map has multiple settings for which blooms you want to see represented. It defaults to all the blooms that we've observed since 2018 when the program began. If you only want to see more recent blooms, you can click this drop-down menu to change the settings. The options here are blooms from the past 30 days, the past 2 weeks, or the past 7 days. So let's click past 7 days to see the most recent blooms represented on this map. Here we can see that 3 blooms have been reported in the past week. Now, if you don't want to use the map, you can scroll down below the map where you'll see this table with each bloom that has been observed. These occur in order of recency, so the most recent bloom observed will be at the top of the table. And we'll navigate to each individual bloom's page later on. This landing page also has some summary information on HABs spanning from the beginning of the program. You can see a tally here of all of the blooms ever reported, 381. Then this pie chart shows the distribution of HABs by microcystin levels, which we talked about before. Hover over each slice of the pie to see what percentage of HABs have fallen into each group. So here you can see that 54.07% of the blooms reported to us have contained microcystin toxin concentrations above that contact recreation limit. We also have this pie chart showing HABs by bloom size. There are 3 different bloom sizes, or extents, that can be reported to us. Small and localized blooms, meaning that they were only observed in front of a few properties. That makes up 32.28% of all blooms reported. If a bloom is large and localized, that means it extended in front of many properties. And blooms are considered widespread if they extend as far as the eye can see. And then there are some blooms for which this data point was not reported, and those are represented by this magenta color here. And then the rest of what's on this landing page are ways to dive deeper into bloom information. You can do that, of course, with these bloom codes that we discussed earlier, or you can explore based on geographic location on the lake using the segment pages. To define geographical locations on the lakeshore, we've divided the Cayuga Lake shoreline into 4 different directional quadrants. Northwest, which goes from Sheldrake Point north. Northeast, which goes from Elmwood Point north. Our southwestern quadrant goes from Sheldrake Point south. And our southeastern quadrant goes from Elmwood Point south. Then within these directional quadrants, we've assigned segments. Segments are defined by points of interest along the lake, as you can kind of see in the names that we've given them. So a point of interest like Harris Park has its own segment Northeast 2. And that's because Harris Park is a public area that people might want to look at on its own. Then there are other segments that go from one point of interest to another, like Northeast 3, which goes from Harris Park to Frontenac Park. It's rare for HABs to occur in the open water as opposed to the shoreline, but this can happen from time to time. To depict that, we've divided the open water of Cayuga Lake into 4 open water segments, following the way the New York State Department of Environmental Conservation has divided this lake. We call these Open Water 1, or Cayuga Lake North End, Open Water 2, or Cayuga Lake Mid-North, Open Water 3, or Cayuga Lake Mid-South, and Open Water 4, or Cayuga Lake South Shelf. Each of these open water segments have their own segment page, just as our shoreline segments do. So, if we want to look at the patterns of blooms that have occurred in one of these segments over the course of the program, we can click on that segment, say Frontenac Park or Northeast 4. First, we'll see this map at the top of the page here, and that has the boundaries of the segment, which are highlighted in green here. And then there are these points, which are still color-coded, and those show us all of the blooms that have been observed within this lakeshore segment since the beginning of the Cayuga Lake HABs monitoring program. So in this case, we can see that this area tends to get blooms with high microcystin toxin concentrations. All the pins here are purple, meaning that the microcystin toxin concentration in them exceeded the contact recreation limit of 4 micrograms per liter that's been adopted by the New York State Department of Health. And just like in our other database maps, you can zoom, you can click and drag the map around to position it the way that you want to. If we scroll down on the page, the next thing we'll see is this graph showing us the trends in HABs reports over the course of the HABs season and across different years. It has the months of the year on the x-axis, and then the HAB report count on the y-axis. So looking at this, we can see that HABs have only been observed in this part of the lake in August and in September. And then it's also color-coded by year. 2020 is this bluish color, 2021 is black, and 2022 is lime green. And a really cool feature of this graph is that it's interactive. So if I only want to compare 2020 and 2022, I can click 2021 here on the bottom and toggle it off. Underneath the graph, we have another table that has individual HABs and their bloom codes. So this is for all of the blooms that have occurred in this segment. And this table also has the date of each bloom, the county that it's in, its extent, the types of cyanobacteria that were found in it, and then the microcystin toxin concentration. So now if I want to look at any particular bloom, I can click here on the bloom. So let's look at bloom 20-3474-B1. This page is called the bloom page, and it's where you can find information about a specific bloom. So clicking on that bloom number took me to that blooms page. These are the same pages that you can access by clicking on individual blooms on the map. So now that we're on this page, we still see this map. You can still zoom into it and click and drag, but this time it is only depicting that one bloom. And that's still color-coded, just as it was on the previous page. And remember that purple means that the microcystin toxin level of this bloom is above the contact recreation limit set by the EPA and adopted by the New York State Department of Health, which is 4 micrograms per liter. And then the segment that it falls in is still highlighted. So then below the map, you'll see a bloom description. And this typically comes from our HABs volunteers. We call them harriers. And they monitor parts of the lake's shoreline weekly for HABs and bring us samples if they do see a HAB. So they'll make these careful observations that you see here in the bloom description, and that gives us some extra information about the bloom that they collected. Now on the left side of the screen, we have information divided into the categories where, when, and what. The where box tells us the water body the bloom is on, and currently all of the blooms on this database have been on Cayuga Lake. It also gives you the latitude and longitude, so you can copy and paste that right into Google Maps if you want to do a little bit of exploration of where it is on your own. It also has the segment of the lake on which the bloom occurred, and that's something that we already touched on. And then it has the county in which the bloom occurred and the extent of the bloom. And this bloom was small and localized, meaning it was only observed in front of a few properties. The when box tells us when the bloom was reported, when it was sampled, and when scientists at Community Science Institute looked at it under a microscope to confirm that it contained cyanobacteria, making it a confirmed harmful algal bloom instead of just a suspicious bloom. So with this bloom, you can see that it was looked at under the microscope the very same day that a volunteer reported and collected it. And the what gives results for the tests conducted in CSI's laboratory. So first we do that microscopic examination where we look at a drop of water under the microscope to see what genus of cyanobacteria is present. So in this bloom, we observed cyanobacteria in 3 different genera: Delicospermum, Microcystis, and Aphanizomenon. And that's depicted by the check mark next to all of these genera under the present heading. The dominant cyanobacteria present in this bloom was in the genus Microcystis, which you can see by this check mark under the dominant heading. And just so you know, sometimes we do see co-dominance, where multiple genera of cyanobacteria are more or less equally prevalent in a bloom. And in that case, you would see check marks under the dominant category next to every genus that was considered dominant. And then the chemistry tests that we conduct on blooms are chlorophyll A and microcystin. Chlorophyll A is an approximation of how dense a bloom is, and a good rule of thumb is that most of the time when there's not a bloom, chlorophyll A will be less than 25 micrograms per liter. Then microcystin is the only toxin for which there's a certified water test, which is part of why that's the toxin we test for. It's also the most commonly found cyanotoxin in New York State. And for microcystin, some good levels to keep in mind are those that we've discussed a number of times throughout this video. So there's the 0.3 micrograms per liter limit, which has been set for drinking water. And then there's the 4 micrograms per liter limit, which is the contact recreation limit. That concludes our tour of Community Science Institute's HABs database today. Remember, you can always access that at database.communityscience.org/HAB. As with CSI's surface water database, it is also possible to download results so that you can peruse that data yourself. And I'll go over the process of doing so with our HABs data in a separate video to be released soon. Thanks for watching.